DevOps Iterations.
And here we are, iteration number 5 of abnormal DevOps iterations, and we have as guest Nikolay Sivko, who is the owner and founder of Coroot. I guess he's going to explain us what it is, what it does, and how it can be useful to us. But first of all, Nikolay, how are you, and what are you doing in this part of your life?
Hey, great. We built Coroot. It's an open source observability platform, but we have a bit different vision on what problems should be solved with observability. Like, as you know, currently we have a lot of tools that help you to gather telemetry data, build your own dashboards, alerting rule, but still troubleshooting still is handled manually. And we aim to turn this huge amount of telemetry data into answers about what's happening right now in your infrastructure, where is the bottleneck, and how to fix it.
And how do you do this? Wonderful achievement, so to say.
I have some background in operations, IT operations, and I worked as a head of infrastructure at some big Russian-based company many years ago. And I realized that when we built observability in the particular company, every time we start from scratch. We have some building blocks such as time series databases, dashboarding tools such as Grafana or something like that. And we start to build our customized observability platform using these building blocks. And my observation is that in most cases, we do the same steps everywhere. And we just instrument high-level overview, then we try to build something that allows us to drill down to the particular service or database or you name it. My idea is that we can automate this using modern technologies such as eBPF. We can gather all telemetry data we need automatically without any changing application code. And we even can build basic structure of dashboards or how you look at telemetry data. We can predefine it for our users. That's a simple idea, but it's something that's pretty challenging to implement because you need to implement eBPF-based collector or agent. It's pretty complicated piece of code because of you have to deal with kernel. Linux kernel, you have to understand how the systems work at the low level. For example, how all communications happens at network level, application level protocols, and so on. But we made a big progress here, and we implemented our own agent that's already installed on more than 20,000 nodes, according to our anonymous session statistics. And it's we care a lot about performance, low overhead, and stuff like that.
Okay, if you don't mind, let's get a bit into details on how Coroot works, what are the components, how you put things together, and feel free to share if you want, or screens or whatever. But so you already mentioned that there is an agent you install on the the container, on the target host, on different kind of application level, or just at the host level because it's based on the eBPF?
Yeah, the first component is, we call it node agent. It's an eBPF-based agent that discovers all containers running on nodes. When I say containers, I mean not only Docker containers or Kubernetes pod or containers managed by containerd. It can be also systemd services on the just bare metal Linux server. And we also consider this as container because the process is run within a C group, and that allows us to gather their resource usage statistics and so on. So the agent gathers metrics, logs, traces, and profiles about every container run of the node and report it. In case of metrics, can be pulled or pushed model. It supports Prometheus export format, and also it can send metrics to our collector through Prometheus remote write protocol. In case of logs and traces, the agent sends them through OpenTelemetry protocol, which is pretty common and pretty like standard de facto, I would say. And for profiles, we had to use our custom HTTP-based protocol. And the next component is Coroot itself. Coroot is, I would say it's UI, telemetry collector, and the engine that allows you to extract meaning from telemetry data, extract actionable insights. So Coroot uses ClickHouse for storing everything except metrics and Prometheus for storing metrics. So Coroot itself manages only metric cache for fast access to telemetry data to build a model of each distributed system. And we also built, we call it cluster agent, the agent that can gather telemetry data from databases such as PostgreSQL, MySQL, and it also does some other stuff like discovers databases or AWS managed databases. It also exports telemetry data. It's like about gathering. But the most interesting part from my perspective is Coroot itself, because it uses telemetry data to build a model of each system. Like when I say model, I mean like application instances joined into applications, because like few containers do the same job. For example, handle HTTP requests for your web service, and we join both of them into applications. So that's how engineers want to see their services, not particular containers, because container doesn't explain, like telemetry of the particular container cannot explain your strange behavior of the application. Then we know underlying nodes of each application instances, so we can.
So we have unwanted phone calls. Okay, go on, please.
We know containers, we know bigger parts, applications, we know underlying infrastructure, we know everything about network between them, and we know how the particular containers communicate with each other. So we can see the big picture of your system. And thanks to eBPF, we can have 100% coverage, because with eBPF you can instrument even legacy or third-party services without the need to change their code. That's the main idea. And next, the most trickiest part, to highlight issues, because it's pretty interesting, because like applications are not built the same. So for some applications, response time of a few seconds, it's okay, but for other services, like 10 milliseconds of response time could be a problem. And that's why we try not to rely on like static thresholds, for example, that 80% of CPU usage, like relative to your CPU limit, it's bad or good. We don't know actually, and that's why we try to analyze problem from the very beginning. From if your applications behave not as expected, we can find correlations down to the stack. Like we can traverse all the dependency graph to find the root cause without using any static threshold. I feel I explain it like in pretty complex manner. I'm not
Yeah,
sure.
no, I wonder how you manage it. I mean, how much configuration you eventually need to do on the agent to pick the right metrics or information and correlate it in a meaningful way for the specific application you want to monitor.
Zero. You
Zero.
don't have to.
You don't do anything. All magically happens.
But you can adjust it later.
Okay. So this installation is just install the agent and no particular configuration usually needed. Usually, you collect a lot of data, I guess, from eBPF, and in some way on the Coroot console you correlate it and you highlight the.
Yeah, we have a set of predefined inspections for every application. For example, we have predefined SLOs. How do you expect your service to perform? For example, we set it 99% of successful requests, and 99% of requests should be handled in less than a half of a second. So, and you can adjust it, definitely, but we have also some predefined inspections like CPU usage on the related nodes with static thresholds. But in our enterprise version of Coroot, you can just select like some anomaly on your latency or failed request chart, and Coroot will find you the explanation of this anomaly. Like two version of the software, and but like when you install Coroot community, you have a lot of predefined inspections that highlights the issues like just in few minutes after installation.
Okay, that's interesting. You mentioned you have the open source code and then an enterprise version. So I guess the question is the business model, I guess, is around the enterprise version of how is different the enterprise version from the community one? What are the
we try to make open source version like useful without any add-ons. Like enterprise version is just we provide you with support, premium support. We provide you the ability to configure single sign-on, role-based access control, and this like AI-powered mechanism where you can explain anomalies. Like all other features are available in our open source product.
AI powered, how? You have your own models, you use some...
We call it AI, but it's not about large language models.
Okay.
It's about applying some math and algorithms to find the relevant events in your system. It's just I believe we can say we use AI without using large language models.
It's not a synonym.
Yes. But these days, when we say AI, users just, wow, do I need to provide my own OpenAI access token or something like that? No, we don't use it. And I believe at the initial stage, we don't need it in this space, just because turning telemetry into some text, it's not a valuable stuff here. Because if you detected the problem, you can explain it better than AI, because you understand the meaning of telemetry. Like language model, unfortunately, doesn't.
You have already structured data, so you don't need to have some kind of abstraction on top of based on language.
But in this space, I know the perfect way to use AI in modern meaning. We can explain unknown log patterns, for example. For example, it can detect some frameworks in your Java stack traces and understand what this particular error message means. But to detect anomalies, I believe, like, I am a skeptic in this space, because I believe, for example, that we don't need anomaly detection for alerting, because we already have the perfect mechanism. It's called SLO traction. It means service level objectives. It's well described in SRE book by Google engineers, and it's like the perfect way to configure your alerting rules. And we built in this into Coroot. So out of the box, you can use the best practices from big enterprise market leaders such as Google. You can implement your SLO traction just out of the box, for example, even if you're a small startup. And I believe that instead of anomaly detection, we need some anomaly explanation mechanisms, where the system helps you to figure out what's happened. And this is more challenging part, because to implement, so you need to structure your telemetry data. You need to somehow explain the system how components communicate, and who depends on which other services, databases, and so on.
Right. So Coroot is based on eBPF, so basically is Linux oriented. Do you have plans to configure, manage it, integrate monitoring for other operating systems or kind of devices or whatever?
Maybe, but it's not about only about the eBPF. We also support open telemetry generated traces and logs. And,
okay,
like
so you can ingest.
Yeah, for example, we can gather telemetry data from AWS managed services, but we don't have to set up. We are not able to set up our agent to directly to these instances, and we use, for example, telemetry enhanced monitoring metrics from AWS, and we integrate it in Coroot, and we can provide users with single pane of glass, even when we cannot use eBPF.
Okay, that's interesting. In terms of sizing, I mean, what is this? The central server where you collect all the data. You have to scale it if the infrastructure to scale is particularly large. How do you handle this?
We rely on ClickHouse for storing like most like heavy telemetry data, such as logs and traces. And with ClickHouse, we can scale it, we can shard it, and we have like the pretty high level of data compression there. In case of metrics, we use Prometheus, but you can use any like drop-in replacements such as Victoria Metrics and Grafana Mimir or something. So you can scale the storage part easily. And we try to focus on analyzing telemetry data and not storing, because you know there are a lot of tools that can do that in more efficient way, such as ClickHouse has unbelievable level of compression, and like it's heavily optimized software to to be able to consume all available resources to provide you with low latency response.
Okay, interesting. So in general terms, in the, let's say, field of observability, monitoring, alerting, this big part of the IT world where you need to somehow control and be aware of what happens. I mean, with eBPF, definitely we have had a lot of progress and totally new, radically different approaches to do some of these activities. How do you feel and think this landscape will evolve in the next years?
I would say eBPF is not something that solve any problems. It's a way to gather telemetry data without the need to change Linux kernel code, for example. Just think of it like eBPF can open any door for you, because, for example, out of the box on a Linux node, you cannot understand. You have only one counter for TCP retransmission events, but you cannot understand the destination of such packets. With eBPF, you can gather this information easily. Not easily, but you can.
Okay.
And it will work on any Linux kernels with eBPF support. So it's a perfect interface to implement your own, not only observability logic, but it also works for security and for network applications, such as you can build load balancer based on eBPF. Yeah, it's but in observability space, eBPF I consider it just a way to gather more precise telemetry data. I wouldn't say it's a game changer, because you can analyze like pretty accurate and precise telemetry data. But we also need to find a way how to, for example, if you gather 5 petabytes of telemetry data and you have enough compute and storage resources to store it, what's next? How to understand it? We need to build more dashboards. We need to, apply some algorithms to analyze it. This is a huge part of work, and I would say a lot of companies, a lot of players on this market are not focused on this problem, and we try to be focused on exactly this task, like extract insights.
And this brings me to my next question. In this expanding world, a more and more complex world of applications, how do you handle the correlation between different data from different systems which are somehow related to the same service, but a lot of telemetry outputs from maybe even different hosts which are somehow related?
I'm not sure I got a question, but
the correlation of the data you get related to the same application, or better, the same service, end user service. If there is a way you do, so an approach you follow to try to correlate different inputs, different telemetry data from different hosts and make them have a sort of high-level view of what is happening for a specific end user service.
Still, I'm not sure that got your question right, but we gather a lot of various telemetry signals, such as, for example, metrics describing resource consumption. But we have some like unusual telemetry signals. For example, we can understand how long the particular process waited for available CPU on the node. And we gather the same metrics concerning every container in our system. Then we know their logs. Then we know that requests to other components. We know TCP connections and everything about them. We can build the model, and then we can say that we know a lot about each particular application. And if, for example, if you have an anomaly on latency chart related to this service, what does it mean? There are the set of hypotheses we can check. For example, this application performs slower than usual because a lack of CPU time. We can check this with metrics. We can know exactly this is true or not. Then, if we checked everything about this particular application and we didn't find anything, the cause can be that queries to underlying database from the service were performed slower than usual. We can compare their latency and find some correlation there. And why this database performs slower. We can check everything about this database as application, and we can check their dependency. For example, if it's a distributed Cassandra cluster, we can check all nodes in the cluster. And at the end, most likely we will find some root cause. And for example, let's talk about a lack of CPU time. Why it can happen? There are like only 3 reasons. The first one is that we hit our CPU limit and our containers were throttled by the kernel. The second one, we can be out of CPU capacity on the node. Why? Because of noisy neighbors, because of ourselves, and so on. And we can check all of these hypotheses automatically using the right metrics. And then I believe that in this way we can identify over 80% of possible issues. But the remaining 20%, we can find correlations in logs. And to analyze logs, like automatically by software, we need to turn them into metrics. That's why we implemented repeated patterns extraction from logs. Our agent analyzes logs and it tried to find repeated patterns. For example, this type of errors happened once a minute with different parameters. And we can cluster them, and we can correlate these log-based metrics with, for example, the number of errors. Can we do so? Yes, for sure. And using predefined set of hypotheses plus analyzing logs can give us like almost 100% chances to find the root cause.
Okay, yeah, that's interesting. In terms of, you mentioned you were very careful about the performance of the agent. Do you have an idea of the overhead of the agent on the system?
Yeah, the thing here is that eBPF provides you with some level of guarantees, because the validator in the kernel checks the program complexity before loading the program. So in this case, for example, like roughly speaking, you cannot use loops in your eBPF programs, and that's why it's like guaranteed that eBPF program itself will not significantly impact your application performance. The second thing is that your kernel space part and user space part communicates through like cyclic buffer. So if your userland program cannot read all the data, it will be overwritten by the kernel part, and you will lose some telemetry data, but still you have guarantees that it will not interrupt processing at the kernel space. So we measured, for example, performance impact in our lab using a load at 10,000 requests per second, and we didn't see any impact like in latency, and that allows us to declare that you can be sure that using eBPF on your production nodes will not impact your application performance. Yeah, our agent definitely will consume some resources, but you can limit it in terms of memory and CPU. Like you should pay some fraction of resources for making your system observable, but you can be sure that your latency of your applications will not be impacted.
Okay, nice. Just to go to more generic question. I mean, it's a question I always do. It's a bit silly, but I still like the answers. How will be the computer that you will be using when you will be 100 years old? When you will reach that age, and you will definitely go there. What kind of computer do you think there will be around? What kind of computer you will be using?
I wouldn't say I have some like strong requirements for a computer. It's like because I try to run everything in the cloud, and that's why just I need a laptop, and that's it. And I'm not a guy who spend a lot of time configured my UI environment and so on. I just I like everything predefined. That's why I like more Mac instead of Linux, because I don't need to configure anything. I like welcome predefined IDE, such as for Gore I use Golang by JetBrains. So I am not a geek who wants to control everything, and that's why my desktop is pretty simple.
Okay. Also, another question I always ask is if you should name one or more people I should invite to the next episodes. You were suggested by Chris Guitert, by the way. So you are here because of this question asked to him. Any person who is particularly interesting to talk with, which you suggest?
I would suggest to talk to Victoria Metrics folks. They do interesting job in optimizing everything related to metric storage and log storage, and they have, I believe, they have a lot of interesting stories about that.
Okay, thanks. Is there a question I haven't asked that you would like to reply to? Something that for you is important to talk about?
Oh, I don't know. I don't have anything in mind right now.
Okay, no, it's just another of those predefined silly questions I like to ask. How do you see the future of Coroot in the next 5 years or 10 years? What is the roadmap, first of all? And how do you think it will impact the industry?
I would say concerning roadmap, we implemented our initial ideas, and now we want to rely more on users' feedback. That's why, for example, we started to implement, comprehensive observability mostly for Kubernetes environment, and now we hear that a lot of businesses run like they have Kubernetes clusters, but they run the huge amount of services on bare metal or dedicated VMs, and that's why we implemented support for that. And I believe that we should hear our users and adjust our plans. And yeah, we will continue to work on root cause analysis automation in Coroot. In terms of company, yeah, we aim to build successful company, like selling our enterprise solution, and we started to work with pretty big players to help them navigate through this dynamic world, and where we face a lot of changes in technology stack every day.
Okay, very well. So, Nikolay, thank you very much for your time and your answers. I think it's quite interesting what you're doing, and I'm looking forward to see how it evolves and how I will going to install it on my systems and see what I can. Any suggestion for the very first early adopter and for beginners? So, what I should do as a beginner to install the agent? How easy is it? So.
Install Coroot. It's just all-in-one package in terms of Kubernetes Helm chart, just try it, and if you have any feedback, reach out to the team, and we are happy to hear our users.
Cool. Definitely. Thank you very much again, and see you. Are you going to any conference next time soon to present also?
No, mostly online.
Okay. So let's see you online.
Yeah, thanks for having me.
It has been a pleasure.
Abnormal DevOps Iterations.